Student, here is Adelani Michael Adelani, your facilitator on this course. This introduction to cybersecurity and an overview of information system security. We are on our lesson 4, week 4, and the topic we'll be treating is understanding TCP/IP and wireless networks. Objective of the course: we should be able to define TCP/IP, then also should be able to know the scope of TCP/IP. Then we should understand the uses of TCP/IP, name 4 layers of TCP/IP. Then also should be able to cite the advantages and disadvantages of TCP/IP. As a form of introduction, also leading to definition of TCP/IP, TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. This is a suite of communication protocol. That is, there are protocols that aid communication over the network. You can use it on the internet. You can also use it in the intranet, that is, network of systems not connected to the internet. Let's dig a little into the history of TCP/IP. This is a model that was designed or developed in the 1970s, and basically is for use in the ARPANET. And this was designed for Unix operating system. It wasn't even for Windows operating system, but for Unix. And it was designed by the DARPA, that is the Defense Advanced Research Project Agency of the United States Department of Defense. Now let's dig deep into what is TCP/IP, that is Transmission Control Protocol and Internet Protocol. It is the entire Internet Protocol tools. Everything that you need to tools that the internet needs is just this TCP/IP. And it is two different main protocols. You have the TCP and you have the IP. Others may be also be included. It's an abstraction layer. When we talk about abstraction, it means you are not actually concentrating. It is a separation from the main course layer between the internet application and the switches which are needed to aid the communication. When we talk about TCP/IP, we talk about how data is exchanged over the internet by providing the end-to-end communication that identify how it should be broken into packets, addresses, transmitted, routed, received also at the destination. How does it work? TCP/IP uses something that we call the client-server model of communication. That is, the sender sends something and it passes through protocols before it gets to the receiver. It's this kind of model in communication. TCP/IP is a tools is classified as what? Stateless. And when we talk about stateless, it means that something is being renewed all the time. Is considered new because it is unrelated to previous requests, something new. Being stateless free up network path so that it can be used continuously. It creates path, then those paths are cleaned up to be used by another protocol. Then the transport layer itself is something that will call stateful because it ensures that communication from A to B is what is received, is assembled at the other destination. Now, what are the layers of TCP/IP? You have four of them. You have the application layer, you have the transportation layer, you have the network layer, and you have the physical layer. Now let's pick them one after the other. The application layer is the origin of where it starts from, and it uses protocol like this HTTP, protocol like FTP, protocol like POP3. This used for mailing, this used for file transfer, this used for web pages, this also used for mail, and simple network management protocol. They are all protocols that happens at the application layer. The payload is the actual application layer, that is where you have lots of loads. Then you have the transport layer, which ensure that what this had started, this will carry it and enable it being delivered to the other hand. You see, responsible for maintaining end-to-end communication. And we use something like this user datagram protocol UDP. Then let's talk about the network layer. The network layer, excuse me, sorry. The network layer is also called the internet layer. It deals with packets. You know, packets are created here. After when this had assigned a heading to it, it transfers to this network layer, which makes them into packet. Packets in the form of having IP addresses on it, IP and Internet Control Message Protocol ICMP, which is used for error recording or error reporting. It gives them, it breaks them into packet and ensure that they are being moved, they are being sent across the internet, where it will now land on the physical layer, which is also known as the network interface or the data link layer. Those are the layers. Now let's look at the importance. That's quite number of importance, like is compatible with all operating systems. This was designed for use in Unix, but as at date, it can work on Ubuntu, it can work in Windows, it can work in so many other uh, operating systems. It is also compatible with all type of computer hardwares and network. It's highly scalable, is a routable protocol, and which means it can determine which is the efficient path to move through in the network. It is also widely used in current internet architecture. What are the uses? It can be used to provide remote login over the network. If you don't have TCP/IP, you might not be able to log on to the e-learning platform. It is also used for interactive file transfer, things like WeTransfer and all of them. Also for FTP, this FTP working here to deliver mail. You talk about mail, you talk about the SMPT, you talk about the POP3, then to deliver web pages and all of them. Those are some of its uses. These are some of its uses. Now, what are the advantages? What are the advantages? What are the advantages of TCP/IP? There are seven of them which are listed here, which it helps in connection between different types of computers. It works independently, support many routing protocols, different routing protocols support it. Then remember, as we said, it has this client server architecture, highly scalable. It can operate independently on its own without any other any application working along with it. It supports several routing and it's light. It's not that heavy. Now let's look at the disadvantages. I have five of them listed here. Five of them listed here. It's very complicated to set up, and also we should note that the transport layer does not guarantee delivery of packets. Yes, you cannot guarantee that the the transport layer will ensure that you have your message being delivered at the other end. But the possibility is there. It's not easily to replace the TCP/IP. Then it gives a open a loophole for attack by malicious people. Before they can attack a particular website, they need the word to use the TCP/IP protocol.